Good afternoon, and welcome to our lesson on the multiplication rule. The multiplication rule allows us to find the probability of two or more events occurring. So let's say 1,300 people were interviewed and asked whether or not they smoke. Out of 1,300, 270 people said yes. So here's our first question. Find the probability that two randomly selected people smoke. Well, watch this. We already know the probability of one randomly selected person smokes. That is 270 over 1,300, like so. And let me draw a line. Now, but we're selecting two people, and this is just the first person. So the second person would actually be 269 divided by 1299. Notice that both the top and the bottom decrease by 1. The reason for that is we started with 1,300, we interviewed one person. Well, we're not going to interview the same person again, so there's only 1,299 people left to interview. So that's where the 1,299 came from. Anyway, we'll multiply that together and we'll have an answer. And the answer for that is 0.043. And just as an extra note, this is unusual because 0.043 is less than 0.05. We'll just mention that. Okay, now part B is asking about people who do not smoke. Well, here's the thing. If there are 1,300 people and 270 smoke, then that means by default, if you subtract, 1,030 people do not smoke. We're going to use the 1030 for our question. So here's how it will work. First, we'll do 1030 divided by 1,300. I'll do the little line through that. Times 1029 divided by 1299. We will multiply it together, and that is equal to 0.628. All right, very good. Now part C says find the probability of at least one. Now, to be right on part C, you have to be right on part B. Because the formula for that is simply 1 minus the previous answer. So when we do that, it's going to go 1 minus 0.628, which is equal to 0.372. And that's our answer. Let's do a few more together. Okay, in our question, 250 students were interviewed and asked if their math is their favorite. Out of 250, 178 said yes. Let's say we select two people at random and we want to see if they both say math is their favorite. Okay, well, what we'll do is we'll start by doing 178 divide 250. And then for the next person, I would like to do 177 divide 249. Let's see if we can get some fraction signs in there. Yes. And if you put that in the calculator, you are going to get 0.506. So if you pick two people at random, there's a 50% chance that both of them like math. Okay, but let's say you find two people that dislike math. Okay, so here's the thing. There's 250 people, and 178 like math. So if you subtract that, that means by default, 72 people do not like math. And we're going to use the 72 to get our answer. Okay, well, let's take a shot at it. So I'd like to do 72 over 250. And then right after, I'd like to do 71 over 249. And let's see if we can get the fraction signs in. All right, let's put this in the calculator. And for that, we're going to get 0.082. So about an 8% chance that 2 people selected at random dislike math. Now for at least 1. Now, to do at least 1, it's going to be 1 minus the previous answer. So 1 minus 0.082, which is equal to 0.918. So that's roughly 92% that if you pick 2 people, at least one will say they love math. Let's do another example. Now, example 3 involves percent. In this case, it says that the percentage of people who have type O blood is 37%. And we're going to choose 3 people at random. It's very easy. First of all, we're going to change percent to a decimal by dividing 100. So 37% divide 100 is equal to 0.37. So we're going to use the 0.37. Now the next step is, because there's 3 people, I would like to do 0.37 times 0.37 times 0.37. And that is equal to, let's see what the calculator says, 0.051. Okay. So now in part B, it says we select 3 people, but we want to see the probability that none of them have type O blood. Well, percents always have to add up to 100. So what that means is if 37% have type O blood, then 100 minus 37 is equal to 63%. Have something else. And 63% is the same as saying 0.63. We're going to use 0.63. All right. All right, so now we have 3 people that do not have type O blood. So we'll do 0.63 times 0.63 times 0.63. And that's equal to 0.250. All right, and then part C says, find the probability that at least one person has type O blood. And remember, the probability of at least 1 is always 1 minus the previous answer. And 1 minus 250 is going to be 0.750. And that's all you do for percents. Let's do one more percent, and then I think you'll be good for this. All right, Texas Lottery sells a variety of scratch tickets. One is called Multiplier Spectacular, which is $20. You decide to purchase 4 tickets, and the probability of winning on one is 29%. Find the probability that a player wins on all 4 tickets. All right, well, first of all, 29% is the same as saying 0.29. That is 0.29. And because the player is purchasing 4 tickets, we're going to do 0.29 times itself 4 times. So 0.29 times 0.29 times 0.29 times 0.29. And if we put that in the calculator, we are going to get 0.007. And as a side note, this is unusual because 0.007 is less than 0.05. In fact, 0.007 is 7 out of 1,000. So if you were to do this 1,000 times, then you can only expect up to 7 times where you'll win 4 times in a row. And you know what? It just doesn't happen. Let's face it. You can lose 4 times in a row, and that's what Part B is going to do. All right, let's say a player loses on all 4 tickets. Well, there's only 2 things that can happen on a scratch ticket. Either you win or you lose. So if there's a 29% chance of winning, then that means there's a 71% chance of losing. And 71% is 0.71. Now let's do the same thing, but use 0.71 instead. So 0.71 times 0.71 times 0.71 times 0.71. And that is equal to 0.254. So what that means is, if you were to buy 4 of these scratch-offs, there's a 25% chance that you're going to lose on all 4, which is a distinct possibility. But that means the odds are you're in favor of winning something. And sometimes you only need one good one. Part C, find the probability that a player wins at least 1. Well, at least 1 is always going to be 1 minus the previous answer. And if you do that, you're going to get 0.746. So what that means is, if you were to buy 4 scratch-offs, there's a roughly 75% chance that you'll win on at least one of the tickets. And sometimes you only need one good ticket. So the lesson here is, if you're going to play the scratch-offs, better to play 4 in a row. There's a good shot that you will win something. Second, whether you win or lose, you can now answer questions 12 through 14 on our homework. Let me know if you have any questions. Otherwise, have a great afternoon.